Okay, so that brings us into the next section, which is limit theorems. Okay. So the first thing we talk about is the definition of a bounded sequence. Okay? So x, which equals xn, is called, let's do proper definition, a bounded sequence provided there exists some m greater than 0 in the real numbers, such that, what do we think?
Some x of n is less than m.
Mm-hmm. For all n in the naturals. Okay. Questions with that definition? Okay. So let's prove our first theorem in this section. Okay. A convergent sequence is bounded. Okay. Do you want to try this one on your own? Or do you want to go through it as a class?
My vote is for class, but I can go either way. You can do it, but
I also vote class.
Okay. We feel class. Okay. We can go through it as a class. Okay.
so when we do it on our own, I just look off Zoe's board.
Okay. So the first thing we know is we have a conversion. So suppose xn is a sequence converging to, let's say, x is our limit. We want to show there exists an m greater than 0 such that xn is less than m for all n in the naturals. Okay, just using our definition here of what a bounded sequence is. Okay. So now let's let epsilon equal. What's a number you would like to use? 3? Okay. Then for all n greater or equal to k epsilon. Right, so we're using what fact here?
The definition of limit.
Yep. So I'm going to actually be a little bit more specific here. Then as xn is convergent to x, there exists k epsilon in the naturals such that, so making sure we're writing all this out a little bit more clearly, okay? For every n greater or equal to 1, we know m greater or equal to k epsilon, xn minus x is less than what? Epsilon or 3. We can just use 3 here. Here. So now we know kind of, hey, if we look at all of these guys, from this point on, we know we can kind of already get it bounded, right? We can get xn bounded for n greater or equal to k epsilon using this fact here. But what about when n is less than k epsilon? Okay. So, bless you. So now, let's consider m equal the supremum xm, the size of that guy, such that m is less than or equal to k epsilon. And actually, we don't need the equals there, so we can take it out. So if we're choosing an index now, that's less than that k. Do we need a sup here, or can we use a max?
Isn't that the same thing?
When is it not the same thing?
If it's only not the same if it's unbounded.
Mhm.
But we're saying it is bounded.
We're saying it's bounded, right? So,
So it is.
and we have a finite set. That's the real.
Oh.
So we have a finite set. So here, we can just say the max. Right? The difference is the sup, right? We might have something that's outside of our set. The max, it has to be inside the set. So for example, if we had 1 minus 1 over n, right? Right. What is our sup here? 1. What is the max though? Do we have a max? No. So that's where it differs. So it's not even necessarily, it's right here because it's infinite. So finite versus infinite allows us to make this a max here. Okay. So now note. For all n greater or equal to k epsilon, we know the absolute value of xn. We're going to use our lovely triangle inequality. With analysis, a lot is, if I don't know what to do, let's see if I can use a triangle inequality. Okay, so we add and subtract x. Okay. Triangle inequality allows us to split it into what?
X to the n minus x plus
Mm-hmm. And then we know x of n minus x is what? Mm-hmm. So x is a limit, right? So the absolute value of that x, is that going to change? No. Okay. 3 plus that, that's not going to change. So now let's think about it. For all. So if m is less than k epsilon, right? We know that that is less than m.
See this?
What about if n is greater or equal to k epsilon? What if n is greater or equal to k epsilon? What do we know? So if I'm just changing my notation here because this was a very specific case where we had k greater n less greater than k epsilon, right? And here this is for everything. So if m is greater or equal to k epsilon, we fall into this case, right? So that means xn is less than this guy. So then no matter what, it's going to be less than this or this guy, so we can use the max here. Does that make sense? What questions do we have?
I used to see it like just straight up set notation. It's like two things, put them in a set. I'm not used to seeing that. It's always like some stuff like that.
And when we could have the union between them, make it a little more complicated.
The union of the set containing m and the set containing plus x.
Mm-hmm. Okay. So then if we let that be in. Okay. L equal the max of m and 3 plus the absolute value of x. Then x of m is less than L for all m in the naturals as desired. Okay. So one thing I would now go back to do, since I changed my letter here, right? I said it's bounded by this L constant. I would now go back here and go, hey, what was I trying to show? I was originally going to show it's less than m. I'm going to change this m to an L now. Why? Just to make sure it lines up. And we'll use a different color because that green works really well in my other classroom, but for some reason it's not very visible here on the screen. Questions, concerns, worries, silence.
Yes, all three, not about real analysis.
Okay. We're going to go ahead. I'll have you guys open your books if you have it with you. There is the electronic version if you don't have it with you.